Hello, Ian Pratt. You were one of the co-founders of Xenserver, which was recently renamed in the Xenserver, and as it was acquired by Citrix. Ian, could you define for us para-virtualization, hypervisors, and or even OS enlightenment, as Microsoft likes to call it?
Well, the work on Xen really started in the University of Cambridge back in, I guess, 2001. And we were really interested in figuring out what the best way of building a virtualization system was. And what we realized is that there were two techniques which were going to, working together, enable you to do a great job of virtualization. So one is getting facilities into the hardware to make the job of virtualizing the platform easier. So getting stuff into the CPU, into the chipset, and in particular into the I/O devices, like the NICs and the host bus adapters. But then also working with the operating system vendors to try and get stuff into the operating system to enable the operating system to call down into the hypervisor to work better in a virtualized scenario. And we really pushed on both of those fronts, working to design network interface adapters that had this special hardware support, and also working to add these extensions into operating systems like Linux, and then other free operating systems, and now even OSs like Windows. You put the two together, and that's where you get this current generation of virtualization software that really is able to achieve great performance, have great security, and provide all the benefits of virtualization.
So Ian, it's quite remarkable that the Xen project is one of the rare open source projects that actually managed to get its feature requests into the big hardware vendors' production. How did you achieve this?
Well, there's a long lead time on getting anything built into hardware. So, Xen has been running for quite a while, since, as I said, 2001, when it was a university project. We were talking to all of the different hardware vendors. We've got to remember that in the early days Xen was sponsored by some of those vendors, and also working with the operating system vendors as well. But also we did things like built network interfaces that had these facilities in, and to prototype them, wrote papers about them, and then companies really began to see that virtualization was important. And let's be fair, VMware had a great part to play in showing the world that virtualization was important, and then I think we've done a great job of showing people how it should really be done.
It's interesting you mentioned VMware, because Xen is an open source project. VMware is to date closed source, and one of the major challenges for people that are looking at which vendor to select is which format how am I going to avoid a lock-in? So how do you think about the open virtual format, OVF, and how do you see an evolution in this field?
Right, so OVF actually came about as a collaboration between us and VMware. So we had been working on a format we called Open Virtual Appliance. We put quite a bit of work into that, and I think we were obviously really concerned about the interoperability issues. And we had the discussion with VMware. They'd been working on a next generation format for their hypervisor, and we actually collaborated together, came up with the OVF spec, and now both sides are implementing that. We'll have to see how it works out in practice. You still have to do a certain amount of preparation of a virtual machine to make it able to work on both platforms, and it's really down to people who are producing virtual appliances to follow the best practice to actually make sure that their VMs are portable. But at least now there's a common file format and metadata format for transferring things between different virtualization solutions, or at least there will be in future when it's implemented and ratified by the DMTF, and all of that boring stuff's happened.
So do you think that once these metadata have been defined on virtual machines and they've been adopted by Xen, VMware, Microsoft, that we'll actually be able to do vMotion or virtual machine relocation between those different vendors?
Doing live relocation, it's kind of like changing the engines on a plane in flight.
Yeah.
That's certainly further down the road. The virtual OVF is really about having a format in which you can package a given virtual appliance, which might actually consist of multiple virtual machines, and install it onto a given hypervisor and have it run there. And Hopefully you'll also be able to use it for moving an installed virtual machine between different hypervisors, but there's a way to go before you can do this live relocation. You know, it's a worthy end goal, but you know, there's a lot of stuff that would need to happen to make that work.
It's one of the things when you see it happening for real now, is one of the wow effects you get in virtualization. Yeah,
no, it certainly is, and you know, it would be nice to be able to live relocate a VM from you know, Xen to Hyper-V or to VMware, but you know, there's a lot of work to do.
Will virtual machine mirroring ever be possible?
Absolutely, it's not only possible, it's you know, has existed for some time. There's some great work which has been done on, well, there are a couple of things to point out here. One, there is a commercial product available on top of Xenserver, which does this today, by a company called Marathon, where they have two virtual machines running on different physical hardware on top of Xen, and they are synchronizing the state between the two in real time, to the extent that you can just walk up to one of the machines, yank the power cord straight out the back, and any users of that application or any service it's providing won't notice that anything's happened, because it instantaneously, or you know, within milliseconds, fails over to the other VM. So that's the commercial product. There's also a lot of work going on in open source. There's a great, there have been a number of projects on Xen. Some work done by the University of Michigan on using a technique called deterministic replay. It's very cool. Work done by University of British Columbia, a project called Remus, which I think is really cool because it works for virtual machines that are multi-processor. So you can have an SMP guest and you can be synchronizing that VM image to another machine. And you know, it's looking like they don't even necessarily need to be in the same building. You might be able to synchronize across you know, a suitably fat pipe, but you know, across the wide area. So you can do it for disaster recovery and things like that. It's all really cool stuff, and we want to get that into mainline Xen.
If you look at virtual machine relocation, the typical reasons people use it for is either to avoid downtime, disaster recovery, high availability, to relocate workloads, or to enforce security policies, either with firewalls inside a virtual machine, or to lock the operating system at the root level. Can you tell us something more about those security policies that you can enforce?
Right, well, one of the nice things you can do with virtualization is you can actually stand outside the OS and look into it and implement some of these facilities which you would normally do you know, using software installed within the VM. You can actually do it outside. So you don't have to worry whether the administrator has actually configured, you know, the firewall correctly, configured, you know, backup correctly in the VM, or configured the virus scanner, because we can actually do all of these things from outside. So, you know, I think that's going to be a far more common thing in future, where you are trying to take care of all of those things within the virtualization layer, so that the administrator of its virtual machine doesn't have to worry about it, doesn't matter if they've messed it up, and you can kind of protect them from themselves. You know, we'll see things like virus scanners be available that you'll run as part of the virtualization stack or virtualization platform, which will scan the contents of all the VMs running on it. If you think about it, it's like taking the you know, the firewall that you might have on the edge of a network, you know, where it connects to the outside world, and kind of pulling that in and putting it closer to the virtual machines that are actually running the applications, and actually implementing that firewall in a distributed fashion across all of the virtualization platforms.
Another exclusive interview brought to you by Virtualization.com.